Just need to share. Got it. So welcome everyone on our weekly community meeting of Cozystack developers. And I have to repeat every time that we have Telegram group where you can join and ask your questions. We also have Slack group in official Kubernetes Slack where you can also join and ask any questions. It's hashtag Cozystack channel. And the first question, do we have any new members this week who would like to introduce yourself? Dmitry, would you?
Hello, my name is Dmitry. I'm working in IT for past 20 years. I'm living and working in Finland. So nothing really special. Kubernetes is one of the products we're using daily. What else?
Thank you.
I guess.
And today in agenda, we have a new Cozystack release. So I'm going to repeat what we introduced in the past. We added a new alerting system based on Alerta, enabled ability to send Telegram notifications, added basic alert set, and also reworked Grafana and updated all the dashboards. Also, there were a few issues with Jinx ingress. Now all of them are fixed and Jinx ingressed with the latest version. We also introduced max connections parameter for Postgres. And also there were a few changes for Fluxity and Kubernetes. The most interesting part is that Kubernetes application was updated. We fixed KubeVirt Cloud Controller Manager. There were an issue that by default, when you have management Kubernetes cluster and tenant Kubernetes cluster deployed inside of it, when you create load balancer service, previously the traffic was sent to all the virtual machines in all the node groups. Since this release and the newer version of Kubernetes in Cozystack, the traffic will be sent only on the specific virtual machines who is serving the services for this traffic. That also makes external traffic policy local working. So finally, this change is introduced. We also updated Kamaji, which also solves a few bugs with control plane, and introduced few fixes for RabbitMQ, CVDFS, for especially for Cozy driver for ordering S3 buckets, and also bump on the newer version of Talos Linux. Now it allows you to use system drive. They have really cool feature for so you can split system drive to multiple partitions, and one of the partition can be also used to store the data. I will post a link later to the document. This is currently not described in our documentation, but I think we have to describe this, and if somebody can check it, please send PR for updated documentation. So finally, since this Talos Linux release, it is allowed to have separate partition for storing the data on the system drive. You don't have to have separate drives anymore. And after this release gets released, we also did some enhancements for alerts. Last time we spoke about Fluxity alerts, that they are very important for us. Unfortunately, I haven't found any any repository which holds these alerts. And so I wrote my own. Now the dashboard looks like this. We have alerts that Helm release isn't succeed, that Helm release is suspended, and also updated all the existing alerts for Kubernetes and all the basic alerts. So now they include resource name and they properly shown in this dashboard. That's all the changes. Do you have any questions, or we can switch to OpenFlower? Okay, no questions. So we still have two discussions to talk about is billing implementation and public API. As about billing implementation, we were thinking internally, so we decided that we need to have a separate billing service, and it should be baked out of two microservices, especially backend and frontend. Backend should go to the metrics interface, especially Victoria metrics, should collect all the metrics and usage. I think that we should to collect what the information should we collect. Actually, CPU usage, memory usage, disk space usage, and Helm chart existence. I think those basic metrics should be in.
Please decipher the last item. I don't understand. What does it mean?
I mean that in Cozystack, every component that we have in dashboard, it is especially Helm chart. So we can calculate every specific time how much time it was existing. So it would allow the service provider to bill per service on per service basis.
Look, there is an issue. So idea to attribute some metrics like usage, and I will explain what I consider like a usage, attribute them to Helm charts. It sounds reasonable, yeah, because we are not operating by basic Kubernetes entities like pods, PVC, and other stuff. But otherwise, we want to have some aggregated statistics which we can attribute to a Helm chart and for particular service which belongs to a particular user. So every Helm chart obviously is placed under some namespace. Yeah, so we can then calculate the total usage for a particular tenant. But there is some drawback here, because usage, it's not like current consumption of some resource. It should be calculated like sum of for CPU hours or CPU seconds, the same for memory and the same for disk space usage. So it's not like a maximum amount of resource used during the billing period. It's some things that is accumulating during the billing period.
Correct.
And what is more important, it's again, we have several approaches how to calculate it. We can say that we are accounting only the available resources, like when we are working with virtual machines. So if you are order a virtual machine from cloud, yeah, you are stating that you need some number of CPUs and some amount of memory, and nobody cares how you distribute it inside of virtual machine. Yeah, so they have a very fixed flavors of very fixed number of flavors of virtual machines that they are providing to you, and it makes billing easier. But if we are talking about real usage of resources, like how many CPU was consumed by some service, yeah, it makes billing much more complex.
Totally agree that flavors can be calculated simpler. And I was also thinking about that every Helm chart actually and every type of resource can include some kind of annotations for the pricing of this resource. And
I think that the next feature request from a consumer of Cozystack platform would be to make a different price schemes for different tenants. So not to bill all the tenants the same price for CPU and memory, but rather to give them some discounts. So in fact, the price will be different. So what does it mean? It means that we should only provide a basic metrics regarding only consumption without any calculation about price. It would be the task for user of Cozystack to apply a proper pricing model. And it will make billing simpler. So we are just streaming the numbers, just plain numbers, like this tenant has such a memory of CPU and memory consumed during the billing period. He used a service called Kafka, Postgres, and I don't know anything else. It was used during the period for some time, and we can attribute some numbers of resource consumption. Dmitry, please proceed.
Yeah, why reinventing the wheel? Why not just billing for execution time for every service, like the Lambdas, for example, in AWS? Like,
yes, execution time, right. You are totally right.
As a service provider, though, the number of deployments of a given service actually is interesting to you, especially if you provide support. So the CPU, like, you might not bill your users directly for the number of support hours that they consume, but you can still bill them indirectly by counting up the number of resources that you claim to support. Whether they actually use the support number or not doesn't really factor into the pricing.
correct. Also, every application can be built different way. For example, the resources for Kafka consumption can be built more than resources for, I don't know, virtual machine consumption. So it makes the scheme more difficult.
Yes,
There might be different SLAs for those
What I'm
customers.
talking about. So we are not just giving to the end user of the system just free numbers, but we are giving like distribution over all kind of services that we have. So one row would be like how many just plain Kubernetes resources this tenant used, and then you will see rows for Kafka, for Postgres, for ClickHouse, for anything else, and the user of the system, I mean provider, yeah, would be able to attribute a different price for different services.
I just thinking if we can make it somehow simpler, wouldn't it be enough to have just these 4 parameters for the basic one? I know that disk space usage can be also split to the different storage classes, like fast storage class, slow storage. But operating on these generic numbers and specific Helm charts, so you can sell especially support hours for every application, I think it might be enough. Am I right or not?
If you want to make a basic billing, you can just stop on the first 3 ones and then agree on the 4th one.
I think the 4th one also should be easy to implement because it is just collects the information from kubestate metrics. So we just need a microservice which go to the Victoria metrics, gets the metrics for the last hour for those 3 resources and stores somehow into ClickHouse or Postgres. Actually, I'm not sure about the backend implementation, but the main flow is like that.
There is an issue because, again, we agreed that we want to provide a proper and reliable numbers to the client. So it means that you cannot just make a snapshots of your Kubernetes cluster state every, like, I don't know, 5 minutes, 10 minutes, who cares, yeah? but you need somehow to understand that some resource was created between this scrape interval and bill the full amount of time it was existing.
I don't see a big problem here, to be honest. Why do you think it is not so accurate?
Because you will just miss, in worst case, the scrape interval time.
Yes, you can, but you can calculate the median between the service was created and metrics type existing. When you have this gap that storage system wasn't available or monitoring wasn't working.
And again, we are returning to the question that we need to have some audit log, which will give us another source of data, and we can compare data which is taken from snapshots and in fact what users was doing inside of control panel, or if some resources were changed inside of the system.
Yeah, this is good topic to discuss, but I'd like to finish this one for the beginning, and I would like also add public IPs or load balancers should be also taken into account. Probably network traffic, but this one can be really difficult to implement because existing tools does not allow you to collect the network data usage. I mean, open source tools, especially OpenCost, doesn't support this. It is supported in KubeCost, but it is not open sourced yet.
We can implement it. I don't think that it's like a very big task, but what probably is more important that you want to provide to the clients of the cluster some kind of different network plan. So let's say one user will have a bandwidth 1 gigabit, another user will 10 gigabit, and somehow limit the amount of traffic they could consume or send to outer world.
What do you mean? I think it should be calculated per pod basis, like every pod, or we can calculate it per tenant. So every tenant can.
Look. So the issue is nobody cares about pod-to-pod traffic. So it's difficult to calculate, and it creates a massive amount of metrics that we don't care about, in fact. But what is really important, the traffic which is flowing inside the system from the outer world. So we can not easily, but in some understandable manner, get the traffic metrics from load balancers.
We can collect some data from Jinx and Grass, but this is not always in use. I'm not sure, maybe we could collect some metrics from MetalLB, which is responsible for providing public IPs. I don't know. Does
As a
anybody have?
customer,
Yep.
I would be more interested in a bandwidth, because like one of the customer might just uploading like just getting the whole freaking bandwidth or channel for some VPN services, and it just eats the whole bandwidth. So basically, we are more interested in providing bandwidth or like guaranteed bandwidth for some of the customers. For example, if they would like to have 1 gigabit connection for 24/7, or a customer just like, I don't know, used some of the small amount of bandwidth, so you just charge them for that amount of bandwidth. Because like most of the traffics, to be honest with you, like on the newer services, let's say Hetzner, it's just unlimited. We don't care about like how much traffic they eat. Some of the customers might use it like during the night. Some of the customers might use it during the day. But by the end of the day, for us, it's more the bandwidth, the whole kind of pipe that we are selling. That's my experience.
That makes sense. So we can actually thinking about not implementing right now, but to solve this on a quota basis. So when you create new tenant, you can specify quota for which will limit you for the network traffic usage. You mean that?
Yeah, that's exactly what we are doing at this point. So the bandwidth and the guaranteed bandwidth for a customer, per customer, or name it.
Again, it does not sound like the first priority functions.
Yeah, from my point of view, these 4 should be enough for the basic billing. The only thing, it should be stored in some reliable database. It can be ClickHouse or it can be Postgres. I especially, personally, I like Postgres more, but maybe somebody has experience with storing this data in ClickHouse.
I'm gonna be nitpick here, but like I wouldn't go for slow storage, maybe regular storage. It's just the name. Sorry for that. Like I wouldn't pay for slow storage. It sounds really silly. Like you mentioned fast storage.
Okay, so it won't be slow storage. Let's
Yeah,
let's
I mean
regular
by
one.
this I mean that it can be calculated different for every storage class.
Yeah, I know it's just a nitpick for me. Sorry for that. Just
Okay,
the name is kind of
please
really.
rephrase, not slow but regular.
Yeah, regular storage. Yes, that sounds really
network,
good.
or just network.
Something like that.
And also you forgot about S3 because it should be built in a separate way.
Correct. Totally forgot about this. Interesting if CVDFS should have some exporter for this, or we probably have to write our own.
Yes. Anyway, so if we are, so it's important to understand what we are discussing. Just MVP or a whole scope of billing implementation.
Yeah. So I think we can take this is for the basic. S3, I really want to, but it might take a lot of time for implement. And then this is phase 2. I will write it down like this.
You can just split it by colors, I think.
Okay, makes sense.
Like red, yellow, and green of your choice.
Green, yellow. Okay. There are also some thoughts. Thank you for them, Georg. And ask about front end. How do you think it should look like? I mean, that shouldn't be front end for the end user, or should it be? I was thinking that billing front end can be done the same way like we implement tenant services right now. I will repeat myself that we have core concept where every service can be deployed.
I have a better idea, sorry. So I have a better idea. I had several experiments regarding headlamp Y for Kubernetes clusters, and I was impressed that they have a plugin mechanism, so you can add any additional functions to it, just simply writing TypeScript or JavaScript application. And I send in a chat that there is a plugin which shows open cost metrics on the dashboard. So every user can easily understand how many money he owes to the owner of the cluster. But it does not cover the question of reports. So it's just something like current consumption and probably some prognosis to the next billing period. No more.
Yeah, that makes sense. That would be really nice to replace our existing dashboard with headlamp. But that might add additional work for just rewriting all existing functions and to implement all the functionality in Headlamp. But that would be really nice to have it. I think right now we have no resources for that, and we have to go with the existing dashboard.
Yes, but again, I want to emphasize that there is a already prepared OpenCost plugin.
Yeah, but we can't just simply use OpenCost, right? We have to use different database for store the data for it.
It depends on the task. So if we are talking about like financial statements, yeah, so then yes, we need to store it in other database, and we need to generate reports and also save the reports, because they would have a legal sense, yeah. But if we are just making some prognosis, we can shorten the path to production and just use already existing solutions.
Yeah, that's what I talking. Right now we have sponsored requests for implementing billing system in Cozystack, and I think this billing system should be used for billing customers of service provider. In this way, we should make a reliable solution, and OpenCost, I think it does not provide you. It might not even work for you in long-term period, so you can't just go and see all the resources usage for 1 month through the OpenCost. OpenCost can be used as a backend for collecting these numbers, but we have to query it every 1 hour and store this data in database, so we can make a front end which should go look into this database and generate report or generate at least some numbers according to the margin the service provider set.
Okay, so two 5 cents. First of all, I'm not sure that OpenCost gives reliable data, because I did not find any warranties about it. So it's okay for FinOps. If you have like an enterprise, you need to like split costs of shared Kubernetes cluster, and you have no strong financial responsibility, particularly to the external clients. Yeah. But if we are talking about billing for service providers, I'm not sure about OpenCost. Probably we need to discuss this with developers of OpenCost, or we have some users of OpenCost in our community. Second thing, that probably we don't need to do any front end for the users. Yeah, so it's okay if we start from sending reports every month to the user's email, to the tenant's email, and that's all. You can just refer to some small clouds like, I don't know, TimeWeb or Hetzner or anything else. Do you have any like current information about consumption? Because in Amazon you have, but Amazon is a major cloud, and we are not competing with Amazon.
Hetzner does have really kind of good consumption stuff, so we are using Hetzner on a daily basis. So yeah, you do have a billing information there and the kind of dashboard, especially for virtual machines, but for bare metal services as well. So yeah, some simple dashboard would be nice to have.
Yes, but there is like a difference, because if you use virtual machines and bare metal servers, it's very easy to understand when the resource was allocated, and there is no large number of flavors, so you can attribute easily the price of item. But if we are talking about shared Kubernetes cluster, because we have a shared Kubernetes cluster architecture, it's a little bit difficult to make a proper assumption and numbers.
Okay, I have another
So it's
idea.
why- so it's the reason why we need a proper mechanism of collecting data, and there is no such a mechanism for shared Kubernetes clusters. So the best solution on market are OpenCost and KubeCost, but again, we are not sure that they are 100% reliable.
Can webhooks be 100% reliable? So every time when you create new Helm release or every time when the new pod is created, it should go through the webhook. And this webhook will collect the information from it and store it into database.
Or otherwise, we can just use a Kubernetes audit log.
Is it reliable?
Yes, it is reliable because look, so if you will go to etcd directly, yeah, so it does not make sense to talk about billing, right? But if you make all changes to the resources through Kubernetes API server, yeah, so audit log is 100% reliable source of truth. The issue is that audit log is overloaded by other requests and changes.
Yeah, I really have worries about using audit log from Kube API server.
Anyway, I want to mention that if we are building secure system, yeah, we need to enable audit log and store it somewhere in reliable place.
I have a concern that using an audit log is basically monitoring state changes. Like, imagine what happens if you lose a message that a node or a pod was shut down. The result would be that you have this node or pod running indefinitely.
Look, Tima, the issue is that if you will lose a node and some worker unjoins the cluster, yeah, and this pod will running indefinitely, the billing, like OpenCost or any other solution you can imagine, it also won't work very well. So
I'm thinking that a more reliable solution is what they call level-based. So something like Cube State Metrics, it gives you the state of the cluster at a point in time. So you know that at this point in time, such and such pod existed and such node existed.
There is an issue. There is an issue because
Yeah.
Kubernetes does not posting the data about pods in a reasonable time frame. So you can make a failure when you see the node is running, yeah, in Kubernetes API, but in fact it was already I don't know, stolen or something else, yeah. So kubelet always send data to the API service with delay, but if the data was sent, you can quote it in audit log. So the nature of Kubernetes is eventual. So if something was written in etcd, you can request it with API service, yeah, but it could there could be a situation when the etcd state does not reflect the real world anyway.
What if we'll teach Cube State Metrics send the data not to the time series database, but into, I know, some Postgres, but still we need to collect. I still don't understand how can we make the data more accurate?
We can install some kind of agents like Telegraph or anything else, which will be running on the node itself, and they will be posting the data to a central database. And in case if there is an outage of network, they are collecting data yeah, not throwing it away like a typical Prometheus exporters, but storing it on the local machine, and when the network will be okay again, they will be able to synchronize all the data that were missing. But it means also we will get an advantage that we can calculate. I know how the real usage of CPU attributed to a particular containers and pods. Because if you will go into container D, you can retrieve the all necessary information to map processes to particular containers and particular pods to which these containers belong. It's how Cloud Advisor and other CSPM tools are working. So they can make a snapshot of virtual machine, yeah, and then attribute everything that was running like a containers to Kubernetes entities.
That sounds like a huge project. I can
Unfortunately, yes.
I can share my experience. I was working with Open Nebula for a long time before I started working with Kubernetes, actually. So I can say how billing was implemented there. They were calculating all the creation requests. So for example, if you create virtual machine, they just calculate the fact that virtual machine was created. If virtual machine become unavailable, the monitoring was considering this virtual machine still continue running. But in a while, some agent could find that this virtual machine is not running, and it can move this state to power off, and then billing will calculate this virtual machine as powered off. So I'm not sure. I think that we can implement the same mechanism in chip by using webhooks, which will take into account the existing Kubernetes resources existence, and also take into account their state. So if pod is not, if pod is running on not ready node, we can calculate it as it powered off, for example. But still looks like a lot of changes. I think the easiest solution for now we can implement is just to base our billing on the requests to the metrics API. And I think that KubeState metrics will provide this data. Maybe it is not very accurate, but at least we can always improve it later if somebody will sponsor this feature for us. And what about audit log? I think there might be a solution better than using audit log of Kubernetes API server. What about using Kyverno or solutions like that, which are passing through all the requests through their webhook? I know maybe Open Policy Agent can also generate log of all the changes inside of the cluster. Does anybody knows any solution like that?
I'm not clearly understand what you want to do, but using Kyverno or OPA for this task sounds like over-engineering.
Just thinking that using Kube API audit log can be really difficult because it's first, we have 3 instances of Kube API server. We have to merge it somehow. That's the first challenge. The second challenge is to find and understand what exactly is happening there. I think there should be some solution for which could generate more reliable audit log, which you can just use. I know, or even collect Kubernetes events. They have enough information when pod is created, pod is running. We can provide this even dashboard for such events.
You don't need to use Kyverno OPA because you can just stream Kubernetes events with just simple Kubernetes events service, and there is many different implementations, and No idea. No idea.
What do you mean by stream what?
So you can stream Kubernetes events. It's another resource in the Kubernetes API, which shows changes in resources.
Yeah, but what do you mean by streaming it?
Just take a K8s event exporter, or how does it called, and stream it to Elastic or other storage.
Yeah. I would like to learn more about this opportunity, because if we have a webhook which configures to handle every resources creation, it also have to generate the report, so you can use some, or even write our own webhook which will calculate the information for every change in a cluster. And in this way we can provide, yeah, but this will provide you just information about post factum. No, it should also collect information about who actually triggered the changes in a cluster. I guess this information should be available through the webhook. So we need to just Google a little bit and find. I think this should provide you really reliable solution for storing the information about every change in the cluster. I just have a worry. So what if this solution will not be available? Actually, a cluster can stack and do nothing until it become up.
Yes, and you also need to consider another different and important thing. So what is more important, to have a correct billing data or to maintain Kubernetes operations in case of billing components are not available?
I still split those two tasks to two different tasks. So I think billing implementation, the easiest part, should be done using kube state metrics and existing Kubernetes metrics. We can always do that better later. And audit log, there's still no answer for this. I think we need to research it more about the opportunity to provide a reliable audit log. So actually, if we use webhook and if we limit user to do the changes only on specific resources, that should be enough to provide audit log from the point of view of service provider. For example, we can create, I don't know, maybe even we can collect the logs of Fluxity, because we actually don't allow our users to change anything except Helm releases in their namespaces.
No idea. I think that we can postpone this discussion and move to the next topic.
Yeah, sure. We have 15 minutes left and we have a lot of things to discuss. Public API. What stops us from providing existing API, Kubernetes API as is? I'm still thinking that a lot of things can be dangerous. So if you provide user and Cozystack dashboard, it might be not secure because they can create, for example, tenants and specify some potentially dangerous options. They can disable isolation. They can enable ingress and also update ingress resource to specify specific public IPs, which will bring this ingress to the IPs of the node. So I have a fear about giving this dashboard as is. Especially dashboard can be given, I think, with some limitations. But if we give access to the Kubernetes API itself, it can be even worse, because we don't actually have any information about potential security issues which can be faced with exploitation. So one of the solution was to generate One of the idea to solve this was idea about creating new control plane API based on KCP. KCP is the project which allows you to run Kubernetes API with no workload. The specific API which dedicated only to custom resources. So we can create additional API server based on KCP and hold all the resources there. They can be shown even better than they are now. So for now, a user operating with Helm releases, and we can translate it to any other different kinds and types of resources, and just translate the copy one resources into from the front end to the back end, and vice versa.
Okay, it sounds reasonable. So what I see like the main vulnerability, let's say, yeah. So if we are providing Kubernetes API as is, we must provide an airbag for users to install an arbitrary Helm release. So it means that in fact user will be able to install any code to the management cluster, not also the predefined set of services like we provided Kafka, Postgres, and other stuff, but any Helm release he can take from the internet. It means a very large surface for attack, and it can ruin the cluster. So we need somehow to limit the user to install only a restricted set of entities. Yes, it could be achieved with Kyverna, OPA, policy engines, yeah, but it sounds like a large task to maintain a proper policies, and it's not so easy. Kingdom, please.
Yes, I was going to suggest Kyverno, but there's another issue that Flux has the multi-tenancy mode, which we have not enabled. So if we don't have additional configuration for each tenant to have a service account in their namespace that provides them the capability, then they will get the Flux system default service account, which has cluster admin. So if they try to reach into another namespace, they'll be able to reach into another namespace with their Helm release if they can create it directly. I'm not saying they can do that now through the UI, given we don't expose the UI to customers. That's another precaution for now. But before either of those things are considered, we should enable the multi-tenancy mode.
We anyway should enable multi-tenancy mode, but right now it's not an urgent thing to be enabled, yeah. And anyway, it won't help us with an installation of arbitrary Helm release with an arbitrary code from the internet. So we have. So what I want to say is that either we will implement a bunch of controls, a large set of controls, yeah, or probably the easiest way, what is talking Andrei, is to implement a separate entry point, probably based on top of KCP. No idea what would work better.
Wait a second. Can you create a Helm chart or Helm release without having Helm repository defined?
I cannot, but I think that I can redefine image name somewhere. So even you will restrict a number of Helm repos in the cluster, yeah, I would be able to install a Helm release. So there is a lot of pitfalls, and and not also Helm repo. I can install Helm release directly from Git repo or from OCI repo, or just refer a Helm chart itself.
Yeah, but current implementation logic does not allow you to specify image anywhere. It allows you to define only specific user parameters. They might be dangerous, like
Andrei,
external true false.
Unfortunately, it does not sound like a robust solution. So if you give to the user a possibility to install a Helm release, it means that if something will go wrong, let's say you just missed type and gave a user an option just forgot about it, to specify image, and you are done. And anyway, if you will give user some additional permissions, like viewing secrets, like, I don't know, listing pods or anything else. So RBAC is a very complex matter. And so, for instance, everybody thinks that Nginx ingress controller is a safe thing, but I unfortunately understood that it has a right to list all the secrets in the cluster. And if in any of the secrets would be stored a Kubernetes admin config, and hacker would be able to got into Nginx ingress controller, you could imagine how much disaster it would create.
Yeah, correct. For now, the most applications which we run in Cozystack, they're secured, and there is default policy which not allow them to go into Kubernetes API. There are some exceptions, especially in Nginx ingress, some initial job for CNPG and Kafka, and also Redis entity, RabbitMQ entity operator, which is also running in user space, in user namespace. But apart of this, the rest are somehow secured. So user...
Yes, and also what we may run. So let's say we have a Kafka resource. We can like set up the name of the Kafka resource, right? Kafka resource is handled by a Kafka operator. Kafka operator obviously has a cluster admin privilege, because otherwise how it would create a Kafka instances into tenant namespaces, right? But if there is some error in the code of Kafka operator, and like, I don't know, like something, SQL injection, buffer overflow based on the name value, yeah. So again, so what I want to say, the security model is very complex. There is a lot of moving parts, and it's very difficult to narrow down what particular settings we need to implement right now to make a system secure by default and not giving more permissions than it is necessary for operation, if we are using Kubernetes API.
Correct. So having separate API is always better than passing user requests directly into existing API. Totally agree on this. So what the best option for doing this? I was thinking about creating controller, which will hold all the dashboard logic and will just operate with separate API. I think that can be simply done with KCP. Actually, I don't know the other solutions. One of the possible solution could be also run the Kubernetes API using Kamaji, but these APIs, I know actually, that might work also as well the same way as KCP. So we will just have plain Kubernetes API which holds just resources for interacting, but still we need to write a controller which will translate all the creation for user-specific resources into Helm releases. Okay, let's keep it as is. Thank you for your thoughts. We also have some pull requests for the review. The first one from Ruben adds external secrets operator into Cozystack. By default, it deploys it as system application. Are there any thoughts why I shouldn't merge it? Okay, the second pull request, adding external DNS configurator, which I found really useful in our case. That would be really useful to allow certificate issue insurance through the DNS of Cloudflare instead of Let's Encrypt. And also the third pull request here is updating Flux to the latest version, probably. Yeah, I think this is already done. That's weird. Well, okay, I'm going to merge it soon. In this way, thank you everyone for attending this meeting. See you next week at the same time.
Thanks. Bye-bye.
Bye-bye.
See you.
Bye.